Welcome to Alibo Market. We're thrilled to have you here. We're excited to have you join us on this coding adventure. Whether you're a seasoned programmer or just starting out, there's something here for everyone. Today, we're diving into the world of C++ programming. C++ is a powerful language that is widely used in various fields, from game development to system programming. Don't worry if you're a beginner. Everyone starts somewhere, and it's okay to feel a bit overwhelmed at first. We're here to guide you every step of the way. Our experienced tutors and mentors are always ready to help you understand complex concepts and solve challenging problems. In this session, we'll explore the fascinating concept of multidimensional arrays. These arrays are a bit more complex than single-dimensional arrays, but they are incredibly useful. Arrays are fundamental building blocks in programming. They allow us to store multiple values in a single variable, making our code more efficient and easier to manage. They help us store and manage collections of data efficiently. Imagine having to manage hundreds or thousands of individual variables. Arrays make this task much simpler. Imagine a container holding multiple items of the same type. This is essentially what an array does. It holds a collection of items, all of the same type. That's an array for you. It's a simple yet powerful concept that forms the basis of many more advanced data structures. Multidimensional arrays take this concept a step further. They allow us to create arrays of arrays, adding more dimensions to our data storage. They allow us to organize data in multiple dimensions like rows and columns. This is particularly useful for representing complex data structures such as matrices or tables. Think of a spreadsheet or a grid. Each cell in the grid can be accessed using a pair of indices, just like elements in a multidimensional array. That's the kind of structure we're talking about. By the end of this session, you'll have a solid understanding of how to use multidimensional arrays in your C++ programs. Multidimensional arrays are arrays within arrays. They provide a structured way to represent data in a grid-like format. The most common type is the two-dimensional array, often called a 2D array. Imagine a table with rows and columns. That's a great way to visualize a 2D array. Each cell in the table represents an element in the array. We can access each element using its row and column indices. Let's say we want to store the scores of 3 students in 4 different subjects. A 2D array would be a perfect way to organize this data. We'd have 3 rows, 1 for each student, and 4 columns, 1 for each subject. Declaring a 2D array in C++ is straightforward. A 2D array is essentially an array of arrays, allowing us to store data in a tabular format, which is particularly useful for representing matrices or grids. We specify the data type, the array name, and the number of rows and columns within square brackets. This structure helps in organizing data efficiently, and makes it easier to access elements using row and column indices. For example, to declare a 2D array named scores to store integer values with 3 rows and 4 columns, we'd write int scores 3 4. This means we have 3 rows and 4 columns, making a total of 12 elements. Initializing a 2D array involves assigning values to each element. This can be done at the time of declaration or later in the code. Initialization helps in setting up the array with predefined values, making it ready for use. We can do this using nested curly braces. Each set of curly braces represents a row, and the values within these braces are the elements of that row. This method ensures that the array is populated correctly. Each set of inner braces represents a row, and the values within the braces represent the elements in that row. This hierarchical structure is crucial for maintaining the integrity of the data within the array. Here's how we can initialize our scores array: int scores 3 4 = 80 75 90 85 70 80 85 90. This line of code sets up the first 2 rows of the array with specific values 90 95 80 85. The final row is also initialized with values, completing the setup of our 2D array. This array now contains all the specified values organized in a clear and accessible manner. Accessing elements in a 2D array is done using the row and column indices. For example, scores 1 2 would access the element in the second row and third column. This allows for precise data manipulation and retrieval. Iterating over a 2D array can be done using nested loops. The outer loop iterates over the rows, while the inner loop iterates over the columns. This is useful for performing operations on each element of the array. Understanding the memory layout of a 2D array is important for optimizing performance. In C++, 2D arrays are stored in row major order, meaning that elements of each row are stored in contiguous memory locations. 2D arrays are widely used in various applications from game development to scientific computing. They provide a structured way to manage and manipulate data, making them an essential tool for programmers. Accessing individual elements in a 2D array is simple. We use the array name followed by the row index and column index within square brackets. Remember that array indices start from 0 in C++. To access the score of the second student in the third subject, row index 1, column index 2, we'd use the following code. In student 2, underscore subject 3 equal sign scores, 1, 2. We can also use nested loops to iterate through all the elements in a 2D array. The outer loop iterates over the rows and the inner loop iterates over the columns within each row. Section 5. Practical example, student scores. Let's put our knowledge into practice. Here's a complete C++ program that demonstrates how to store and access student scores using a two-dimensional array. This program declares a two-dimensional array, initializes it with student scores, accesses a specific score, and prints it to the console. Section 6. Exploring three-dimensional arrays. Now, let's step into the world of three-dimensional arrays, or 3D arrays. These arrays add another layer of depth to our data organization. Imagine a cube instead of a flat table. That's a good way to visualize a 3D array. Each cell in the cube represents an element, and we can access it using 3 indices: row, column, and depth. For example, we might use a 3D array to store temperature readings for different locations over time. We could have rows representing locations, columns representing days, and depth representing hours. Section 7. Declaring and initializing three-dimensional arrays. Declaring a 3D array is similar to declaring a 2D array. We just add another dimension to the square brackets. To declare a 3D array named temperatures to store floating point values with 2 locations, 3 days and 4 hours, we'd write C++ float temperatures 234. Initializing a 3D array involves nesting curly braces even further. Each set of outer braces represents a location, each set of middle braces represents a day, and the values within the innermost braces represent the hourly temperatures. Section 8. Practical example, temperature data. Here's a C++ program that demonstrates how to work with a 3D array to store temperature data. C++ hash include using namespace std, int main, float temperatures, 234, equal sign, 25.5, 26.0, 26.5, 27.0, 27.5, 28.0, 28.5, 29.0, 29.5, 30.0, 30.5, 31.0, 24.5, 25.0, 25.5, 26.0, 26.5, 27.0, 27.5, 28.0, 28.5, 29.0, 29.5, 30.0. Set count temperature at location 1, day 2, hour 3, temperatures 0, 1, 2. Endl, return 0. This program declares a 3D array, initializes it with temperature data, accesses a specific temperature reading, and prints it to the console. Section 9. Conclusion and next steps. This is the final section of our course on multidimensional arrays in C++. You've come a long way, and it's time to wrap things up and look forward to what's next. Congratulations. You've now learned about multidimensional arrays in C++. This is a significant milestone in your programming journey. Understanding multidimensional arrays is crucial for handling complex data structures and solving intricate problems. You know how to declare them, initialize them, access elements within them, and manipulate them to suit your needs. This knowledge will be invaluable as you continue to develop your programming skills and use them in practical applications. Whether you're working on a small project or a large-scale application, multidimensional arrays can help you organize and manage your data efficiently. Remember that multidimensional arrays provide a powerful way to organize and manage data in your programs. They allow you to create more complex and dynamic data structures, which can be essential for certain types of applications. They're especially useful when dealing with grid-like or tabular data structures. For example, if you're working on a game that involves a grid-based map or a spreadsheet application, multidimensional arrays will be your go-to tool. In our next session, we'll delve into the world of pointers in C++. Pointers are a fundamental concept that every C++ programmer needs to master. They allow you to work with memory addresses directly, giving you more control over how your programs use memory. Pointers are a fundamental concept in C++ that allow you to work with memory addresses directly. This can lead to more efficient and powerful programs, as you can manipulate memory in ways that are not possible with regular variables. They open up a whole new level of flexibility and power in your programs. With pointers, you can create dynamic data structures like linked lists, trees, and graphs, which are essential for many advanced algorithms and applications. Be sure to subscribe to Alibo Market on YouTube so you don't miss out. By subscribing, you'll stay updated with our latest tutorials and programming tips, helping you continue to grow as a developer. Thank you for joining us, and we look forward to seeing you in the next session.